We're going to have a look at our IRB interfaces now. This is our integrated routing and bridging interfaces. If you're coming from the Cisco world, you'll know this as an SVI interface. Problem we have is that on server 1, we can't ping server 2 because they're in completely different VLANs. Let's have a little look. Let's go on to server 1, which is there. Okay, so let's ping. Just show we do have internet reachability. That's great, fantastic. Okay, let's see if we can ping server 2, which is actually on the same switch. So ping 10.10.200.2. Okay, so there's no gateway found. So because there's the server knows that if the address that it needs to get to is outside of its own subnet, then it needs to have a default gateway. So that is one of the main reasons that you're going to be using a IRB interface. So let's go and say bung one on spine 1, and we'll do 2 SVIs, one for VLAN 100 and one for VLAN 200, and then we'll see if we can ping across, get some inter-VLAN routing goodness going on. Okay, so let's go into configuration mode. So when we're creating our IRB interface, it is literally just a layer 3 interface. So we configure it exactly like any other layer 3 interface that you'll configure. However, instead of having the XE or the GE prefix, it's going to have the IRB prefix. So let's do set interface IRB unit. Now you can give the unit number anything you want. You can call it unit 1, unit 77, unit 390 if you like, but it is best practice to have the unit number the same as your VLAN ID, only because it makes things look better, and when it comes to diagnosing problems, it's easier to have both of them the actual same. I mean, like I said, you can put it as a completely different unit, assign it to the VLAN afterwards, and it will work fine. But if there's a problem, then you want to be easily pick out IRB.100. That belongs to VLAN 100, so it just makes things easier for you in the long run. So we do unit 100, and now we're like any other IP address that we're going to put on. So it's family inet, and then address is going to be, say, 10.10.100.254/24. Okay, so I said /24, but I put a .24. That was a bit silly. So /24. There we go. Sweet. Now let's do the same for VLAN 200. So let's do set interface IRB unit 200 family inet. Address will be 10.10.200.254/ not dot 24. Sweet. Okay, so what we need to do now that we've created our IRB interfaces, we need to bind them to the actual VLAN itself. Relatively simple process. So we'll do set VLANs, and if you recall, it was customer 1 for VLAN 100, and it's just L3 interface, and it's going to be IRB.100. Nice and easy. Let's do the same for VLAN 2 or VLAN 200, which is customer 2. So we'll do set VLANs customer 2 layer 3 interface IRB.200, and let's do a show pipe compare. Okay, so when we commit this, we've built our two IRB interfaces, unit 100, unit 200, with the respective IP addresses, and we've created, well, we added rather, layer 3 interfaces into both customer 1 and customer 2 VLANs. Okay, let's commit this. Now this in its own won't do anything, because on our servers all we've put in is a basic IP address. We've not put a default gateway, so we need to amend them with this default gateway. So let's have a quick look on server 1, and let's do IP, which will be 10.10.100.1/24, and the default gateway is 10.10.100.254. Sweet. Okay, and let's do the same for server 2. So server 2 is going to be IP 10.10.200.2/24, and the default gateway is going to be 10. Oh, blimey! No. That's better. 10.10. I've got fat fingers today, literally. 10.10.200.254. There we go. That's sweet. All right, so let's jump back on now to server 1, and the proof is in the pudding. Can we do some inter-VLAN routing? Let's have a look. Let's hold our breaths. Timing out. There we go. Fantastic. Okay, so what's happening here is we're sending traffic. So let's close that down for a moment. Close that down. Sweet. Okay, so what's happening is that we're sending traffic from server 1 to the leaf. The leaf is sending it to spine 1, which has our default gateway. Spine 1 is sending it back down to the leaf, and the leaf is now sending it to server 2. So this may not always be the most most efficient way of doing it. I mean, it is the only way really to to have an IRB interface, or you could actually be even worse and have your gateway at the top have the layer 3 interface, which means it's even more hops. However, sometimes people or companies will put the IRB interface on the actual leaf layer as well. I mean, it literally depends. I mean, I've not really come across personally any reason why your IRB interfaces can't be on the spines, but some places like to keep them on the leaves. But anyway, we digress. Now that's all well and good. We've got on our IRB interface on, but we're only dealing with this one switch. So let's have a look on and just quickly amend server 3 and server 4's IP addresses, so we can sit there and see if we can get some traffic going to the other switch as well. So let's have a look at server 3. All right, so server 3's IP address is 10.10.103. So let's do IP 10.10.100.3/24, and the default gateway is 10.10.100.254. And let's have a look on server 4, and let's change it to IP is going to be 10.10.200.4/24, and the default gateway is going to be 10.10.200.254. Great stuff. Okay, so let's go back onto server 1, and let's see if we can ping server 4. We'll just wait for this to maybe go through. There we go. Fantastic. Alrighty, now let's jump on to server 2, and let's see if that can ping server 3, which is on the other switch. So ping 10.10.100.3. There we go. Absolutely fantabulous. So now we're at the position where we can go up to the leaf, up to the spine, and the spine is now able to send the traffic to another leaf switch, which is able then to send the traffic wherever it needs to go. So everything seems fine. So we've now got our inter-VLAN routing on with our IRB interfaces. Nice and easy. Anyway, I hope you've enjoyed this video, and I look forward to seeing you in the next one.